We start on the vernier caliper. We are going to discuss this in 3 steps. Number 1, we look at the main parts of the main calipers. Number 2, we check on how we take the readings of the vernier scale. And number 3, we demonstrate the correct reading of the combined scale. So, vernier caliper consists of one fixed jaw which has the main scale. The main scale has the main divisions which are in centimeters and the subdivisions which are in millimeter. We then have a movable section. We call it the movable jaw. It comes with some different parts. We have the vernier scale, which consists of the vernier divisions. We have the sliding wheel. We also have a screw at the top there to fix the jaws when you are taking the readings. And on this other end, we have a protruding metal that is used to measure the depth of a hole. The metal is not wide to make it possible to go through small holes. I can demonstrate on how this movable jaw is connected to the protruding metal, and you can see both of them are sliding together, and this makes our calipers possible to do 3 different measurements. We can take the size of the external diameter using the lower jaws. We can take the size of the internal diameter using the upper jaws, and we can take the depth of a hole. We start by crossing the 2 jaws completely together, and one thing you notice is that the zero marks, both the zero mark, the zero from the main division and the zero from the vernier divisions are coinciding. That's where we start, and any length that is to be measured is the distance between the 2 zero mark. Any length that is to be measured is the distance between the 2 zero mark, and therefore this particular case we have 0 reading because the 0 mark on the main scale and the 0 mark on the vernier scale are both at the same level. Okay, I now demonstrate on how the vernier divisions are made to slide over the main scale. Before any sliding, the reading of the vernier is 0.00 centimeter. If I do the first move, I hope you notice that division number 1 on the vernier scale coincide with the 1 millimeter mark on the main scale. The second move, the second division on the vernier scale coincide with the 2 millimeter mark on the main scale. I repeat the same, the third move. The third move, you realize that the third division on the vernier scale coincide with the 3 millimeter mark on the main division. We continue sliding. The next one, the fourth step, the fourth division on the vernier scale coincide with the 5 millimeter mark on the main scale. If I continue like that, you realize that only one division on the vernier scale is coinciding with a mark on the main scale. So we are now at mark number 6 which is 0.06 centimeter. We can move on. We are now on the 8th mark is now coinciding, which is 0.08. We move on to the next, which is move number 9. The reading is 0.09 centimeter on the vernier scale, and then before we hit the last move, there's a very interesting kind of a fact that I would like you to notice, that by the time the 10th vernier divisions gets or coincide with the mark on the upper scale, then the zero mark on the vernier coincide with the 1 millimeter mark. And in that case, I have taken you through the 10 steps to subdivide 1 millimeter in the main scale into 10 subdivisions. How do we take the recording? Okay, it's good to note that 1 millimeter is equivalent to 0.1 centimeter. How do we take the recording? The correct recording is a combination of both the reading of the main scale and the reading of the vernier scale. So the correct reading is a combined kind of a value. We normally start by taking from the main scale. We take the main division, we count the main divisions. In my case, I have used X to symbolize, and this gives us the first value followed by a decimal. We then take the count of the subdivision still from the main scale. Assuming we get Y, this gives us the first decimal. Then we count the number of divisions in the vernier scale. Assuming we get a Z, this one now gives us the second decimal, and followed by the units, which are the centimeters. That's how we take the reading. Now let's get to the actual taking of the sizes. I have a pipe with both external and internal diameter. I start with the external diameter. So I'll first of all count how many main divisions in the main scale are covered. In this case, you can see from 0, 1 is covered, but 2 is not completely covered. Therefore, I'll start by recording 1 point. The next step is to count the number of the subdivisions that are covered, that are behind the 0 mark. So if you count, this is the first one and the second one. The third one is not yet covered, so I'll record mark number 2, and this one gives us the first decimal, which is a 2. From there, we take the count on the vernier reading, which division is coinciding with the upper scale. And if you move with me, you can see from 0, 1, 2, 3, 4, 5, 6, and it is division number 6, which now gives us the second decimal. So if you now combine the two, the correct reading is 1.26 centimeters. Okay, we still use the same vernier caliper, but now we use the upper jaws. We refer to them as the inside jaws. We adjust them to fit on the inner diameter. and again we take the count from the main scale. We count the main divisions. You can see from 0 to 1. Remember, our measurement is between 0 mark on the main scale and 0 mark on the vernier scale. Our 0 mark has not covered the first main division, and therefore we record 0. If we count the subdivision, that is 1, 2, 3, 4, 5, 6, 7. So there are 7 subdivisions from the main scale that are covered, and therefore I get my first decimal, which is a 7. We move on now to count the number of decimals in the vernier reading that are coinciding with the upper scale. Move with me from 0. We start with 1, 2, 3, 4, 5, 6, 7. It is division number 7 that is coinciding with the upper scale, and therefore we obtain our second decimal, which is 0.07. Now if you combine that, you get the correct reading is 0.77 centimeters. We now try our vernier caliper on obtaining the depth. I have a cylinder here which is hollow. I need to get the depth, so I'll use the protruding metal to get the depth. I adjust, I tighten the screw after getting the correct position, and then I proceed by counting the number of steps in the main division. Okay, the main division is from 0 to 1, that is covered, but the second one is not fully covered. I still insist our distance that we are measuring is between the two zeros, the 0 on the main scale and the 0 on the vernier scale. So you can see from the main division 1 is covered, so I record 1 followed by a dot. Then the subdivision, we count 1, 2. The third one is not fully covered, so I'll record 2. Then to obtain the second decimal, I'll now count the number of divisions on the vernier scale. I hope you are still moving with me. You have the 0, 1, 2, 3, 4, 5, 6, 7. It is division number 7 that is coinciding, and therefore if you combine, you get it as 1.27 centimeters.